Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the last topics in the 5th unit and the last topic in the signals and systems also. In this, the inverse transformation examples, we completed the 3 methods. Next one, convolution method. Convolution method is the last method in the inverse transformation. First one is a power series method, second one is a partial differentiation method, and third one is residue method, and the last is a 4th method is convolution method. We know the convolution of time domain is a product of the frequency domain, nothing but Z domain here. Take the one example here, Z square by Z minus 2 and Z minus 3. I modify this x of Z is Z by Z minus 2 and Z by Z minus 3. Take one function is x1 of Z and second function is x2 of Z. Okay. And you can find the inverse transformation with Z is greater than the 3. Z is greater than the 3. Greater than means irrespective of the value, you can write it is in the right hand side only. The first one, x1 of Z, Z by Z minus 2 means 2 power n mu of n. Why? Because it is a greater than. And x2 of n is a 3 power n mu of n. Z by Z minus a is nothing but a power n mu of n. We got the 2 functions in the time domain. What is the convolution? x1 of n and the x2 of n. Find out using the formula 2 power n mu of n with the convolution of 3 power n mu of n. What is the formula here? Sum of k equal to 0 to n. Actually minus infinite to infinite. Why I am taking that 0 to n? Because it is a multiplied with the mu of n is there. Okay. According to the function x1 of n with the convolution of x2 of n, the formula is sum of k equal to minus infinite to infinite, x1 of k, x2 of n minus k. This is a formula for the convolution of discrete time function. So sum of k equal to minus infinite to infinite. What is the first one? x1 of n is in terms, now the change is as a k. 2 power k mu of k. In this 2 power n mu of n, now it is I am changing the variable as a k, and x2 of n, 3 power n mu of n. So I write it as a 3 power n minus k because the k instead of k there is n minus k, mu of n minus k. What it matters? We know the mu of k is equal to 1 for k is greater than or equal to 0, and mu of n minus k is also 1 for n minus k is greater than or equal to 0, and n minus n is greater than or equal to k. N is greater than or equal to k, or k is less than or equal to n. Now k is greater than or equal to 0 and k is less than or equal to n means within this range there is a 0 to n. Now I am changing this as a sum of k equal to 0 to n only, because less than or equal to n. The intersection range, the 2 power k and 3 power n minus k. And the 2 functions mu of k and mu of n minus k, the value is a 1. And here the summation is a k, taking only the k values. Power n is a constant, 3 power n if I am writing. The sum of k equal to 0 to n, 2 power k, 3 power minus k. And again, you can write the 3 power n, and becomes the value is a 3 power k and the 3 power minus k. Here both the bases are not the same. Both the bases are not same functions. Got it, my dear students? So now I am writing the sum of k equal to 0 to n, the 2 power k and the 3 power k, because it is the inverse. That is equal to 3 power n into sum of k equal to 0 to n, 2 by 3 whole power k. Now use the formula, sum of n is equal to n1 to n2 e power n. You know the formula is there. That is 3 power n into whole multiple. K is equal to 0. Means 2 power 3 whole power 0 minus 2 power 3 n2. N2 is nothing but n. N2 plus 1 whole divided by 1 minus a, 2 by 3. What my students? 3 power n into anything power 0 is a 1, and 2 by 3 whole power n plus 1 and whole divided by, and this value denominator is a 3 minus 2. Take the 3 minus 2 is a 1, 1 by 3, 1 by 3, and it becomes of numerator 1 by 3, and it is a 3 power 1 only. Finally, you can write this function as a 3 power n plus 1 whole multiply with 1 minus 2 by 3 whole power n plus 1. The x of n is equal to, by using the convolution formula. Using this convolution property, first of all, you can divide the given equation into two parts. One is x1 of z and the x2 of z. Write the time domain function according to the formula, standard formulas, and apply in the, substitute in the convolution formula and simplify. You'll get the 3 power n plus 1 into 1 minus 2 by 3 n plus 1. Got it, my dear students? This is the same thing we got 3 power n plus 1, 1 minus 2 by 3 n plus 1. Because it is a greater than, you can multiply with the mu of n and the mu of n. Both the functions. And you see here the 3 power n plus 1 and multiply the 3 power n plus 1 in the denominator get cancelled. 2 power n plus 1 into mu of n. And another example we have here, z by z minus 1 and z minus 1 by 2. Take the function as z by z minus 1 as a x1 of z and 1 by z minus 1 by 2. And x1 of n, 1 power whole power n mu of n minus, and this value is mu of n. x2 of n is only it is not in the form of z by z minus a. When it is a z by z minus a, then only we have a power n mu of n. But 1 by z minus a inverse z transformation is 1 by 2 whole power n minus 1 mu of n minus 1. One sample is shifted towards the right side. Z by z minus a value. Got it, my dear friends? 1 by 2 whole power n minus 1 mu of n minus 1. One sample. So a power n minus 1 mu of n minus 1 is a z by 1 by z minus a. Remember this one. This is also the standard function. A power n minus 1 mu of n minus 1 is 1 by z minus a. So we get the 1 power n mu of n for the first one, and second one is 1 by 2 whole power n minus 1 mu of n minus 1. And using this convolution formula, the substitute 1 by 2, the mu of k, I'll explain. The sum of k equal to minus infinite to infinite, x1 of n, x1 of k, x2 of n minus k. What is the x1 of k? We got 1 whole power n mu of n. Sum of k equal to minus infinite to infinite, 1 whole power k mu of k, and second function is 1 by 2 whole power n minus 1. Actually, it is a n minus 1. Instead of n minus 1, n is changes as n minus k minus 1. And mu of n minus k minus 1. What it matters to us. So mu of k is equal to 1 for k is greater than or equal to 0. And mu of n minus k minus 1 is equal to 1 for n minus k minus 1 is greater than or equal to 0. Got it, my dear students? So n is greater than or equal to k plus 1. Okay. For n minus 1 is greater than or equal to k, and k is less than or equal to n minus 1. So using these two relations, you can write the summation is the sum of k equal to 0 to n minus 1, 1 power k, anything power 1 is a 1 only, 1 by 2 whole power n, and another one is there 1 by 2 whole power minus of k plus 1, minus of k plus 1. That is equal to sum of k equal to minus 0 to n minus 1. 1 by 2 is a common term here, 1 by 2 whole power n. And here it is there, the 1 by 2 whole power minus k. So if I am writing this function as 1 by 2 whole power minus 1 whole power k, and 1 by 2 whole power minus 1. Got it, my dear students? It is in the form of 1 by 2 whole power minus 1. Or in the form of, you can say the 2 power minus 1, the 2 power k it is. 2 power k. 1 by 2 whole power minus 1 is already there here. 1 by 2 whole power minus 1. And here the 1 by 2 whole power again. Take these as a totally the common. 1 by 2 whole power n minus 1. And it becomes of sum of k equal to 0 to n minus 1. Now 1 by 2 whole power minus 1 is nothing but 2. 2 power k. 2 power k. Now it is in the form of sum of n is equal to n1 to n2 a power n. What is the formula? We got 1 by 2 whole power n minus 1 whole multiply with a power n. So 2 power 0 because it is a n1 is a 0, and 2 power n2 plus 1. n2 plus 1. n2 is n minus 1 plus 1, and whole divided by 1 minus 2. So 1 by 2 whole power n minus 1 whole multiply with 2 power 0 is a 1 minus 2 power, and this is becomes get cancelled, 2 power n whole divided by minus 1. Minus 1. Got it, my dear students? So now if I am taking power n minus 1, take this minus, you can multiply 2 power n minus 1. 2 power n minus 1. What is the final answer? We got 1 by 2 whole power n minus 1. Here I am taking 1 by 2 whole power n minus 1, 1 minus 2 power n. Simplify this one. So 1 minus 1 by 2 whole power n minus 1, and because it is a 1 minus, if I am taking the plus value, simplify it is a 2 minus 2 into 1 by 2 whole power n mu of n. Okay, into mu of n. Why it is a mu of n? It's mu of n because it is a positive value they are asking. Then it becomes of mu of n. Okay, why it is a minus is there? 1 minus 2, it becomes a minus here. If I multiply this as 1 by 2 whole power n minus 1, the 2 power n minus 1 minus 2. So 1 by 2 whole power n and the 2 power n. It becomes of 2 power minus n into 2 power n minus 1. So I'm writing the 1 by 2 as a 2 power minus 1. Multiply this function 2 power minus 1 and the 2 power n becomes of the 2 power 0 value. N minus 1 minus 2. So it is not the n minus 1. Okay, now we can multiply 2 power n minus 1 plus minus of n minus 1. It is multiplied with the 2 power n and minus 2 power minus of n minus 1. Okay. And now it becomes of 2 power minus n plus 1 and the 2 only. The first term becomes a 2 and second term is minus 2 power minus n and 2 power plus, that is equal to 2 into 2 you can multiply 1 minus 2 power n into mu of n. Is only there, right? It is a 2 power minus n is a 1 by 2. So 2 minus 2 into 1 by 2 whole power n mu of n. Otherwise, this becomes of 2 you can take as a common. 1 minus 1 by 2 whole power n mu of n. Got it, my dear students? Mu of n. So using this convolution method, you can find out the inverse jet transformation. So we find the power series or the long division method, and second one is a partial fraction expansion method, and third one is a residue method, and the last it is a convolution method. The last topic here, linear time invariant system. Linear time invariant system. So the x of n, the discrete time signal is given to the system. That system is a linear time invariant system, h of n. To get the response is a y of n. The response is nothing but get the output. The input is a discrete time signal. It passes through the linear time invariant system. The linear and also the time invariant. For the linear time, discrete time system will be represented by the difference equation. Remember, my dear friends, by the difference equation. What is the difference equation? Sum of k equal to 0 to n is a finite duration here. A suffix k, y of n minus k, and that is equal to sum of k equal to 0 to m, here the capital M, my dear students, b suffix k x of n minus k. So difference equation. X is nothing but the input value and y is the output function. So here the input function is x. Here we represented the x is x of n minus k. That k value having the 0 you can substitute, we'll get the x of n. And 1 we can substitute x of n minus 1. And so on. Means it depends upon the present and the past inputs. This is a past input. Okay. And similarly, here in the left hand side, you can observe, you can substitute k is equal to 0. It becomes of y of n and y of n minus 1. This is y of n is a present output. Y of n minus 1 is a past output. See, in the input and output, it is not at all depends upon the future inputs and the future outputs. Only it is depends upon the present and the past inputs, present output and the past outputs. Okay. And now we know the Z transformation, x of n, the Z transform is x of z. And here the Z transform of the shifting function, time shift function. The time shift function we have x of n minus k is x of z. Whatever the samples we are shifted towards the right side, can take as a negative powers of z, z power minus k. If x of n plus k is there, you can get it is a z power minus k is becomes of plus k. But it matters, students. Now, use the sum of k equal to 0 to n a suffix k z power minus k y of z. And apply the Z transformation on both sides of this equation. The sum of k equal to 0 to n a of k. And what is the shifting operation we are applying here? Z power minus k y of z and z power minus k x of z in the right hand side. So y of z by x of z is a transfer function of the system function. Transfer function or system function we are calling it as. That is equal to sum of k equal to 0 to m b suffix k z power minus k up to this, and here also divided by sum of k equal to 0 to n a suffix k z power minus k. When I am taking the y of z by the x of z cross multiplying, you can call it as a system transfer function or system function. H of z is equal to sum of k equal to 0 to m b suffix k z power minus k whole divided by sum of k equal to 0 to n a suffix k z power minus k. Got it, my dear student? System transfer function, or it is a system function. Transfer function means output by the input. Got it, my dear students? Then indicating that the impulse response or the impulse response of the transfer function. Impulse response means the y of n is y, that is delta of n, or the h of n we are calling it as the impulse response. Impulse signal is a delta of n. Impulse response is a h of n. After applying the z transformation of this impulse response, we are getting the h of z, nothing but the system transfer function. Okay. Delta of n is given to the system linear time invariant system. The response is impulse response, nothing but the h of n. So the impulse signal passes through the system, we'll get the impulse response. And this impulse response, whatever we got, apply the z transformation, we'll get the h of z, calling it as y of z by the h of z is a system transfer function or system function. Got it, my dear students? So given function, the y of n minus 3 y of n minus n is equal to x of n. It's a linear time invariant system of the differential function. Apply this transformation on both sides for the given function. Y of n is nothing but y of z here. Minus 3 y of n minus 1 z power minus 1 y of z. That is equal to x of n. The transformation is x of z. Take the y of z is a common here. Y of z into 1 minus 3 z inverse x of z. So y of z by x of z is equal to 1 by 1 minus 3 z inverse. Or you can also written as a z by z minus 3. Z minus 3. According to that, it is a z by z minus a. The a power n mu of n. What is the z transformation here? A power n mu of n, z transformation is 1. In the positive powers of z is z by z minus a. In the negative powers of z is a 1 by 1 minus a z inverse. Okay. Now here the positive powers of z, instead of a, 3 value is there. So what is the h of n is equal to 3 power n mu of n. Impulse response. Calculate the system impulse response. System impulse response, or it is a transfer function the given function, it is y of n minus 3, y of n minus 1 is equal to x of n, h of n is equal to, we got the impulse response. Similarly, take the second example. You can see here y of n plus 0.5 y of n minus 1 plus 2 into y of n minus 2 plus 3 into y of n minus 3 plus 0.5 y of n minus 1 is equal to 3 into x of n plus 5 into x of n minus 2. Apply this as a transform on both sides. What is the y of n? The transformation is y of z plus y of n minus 1, the transformation is z power minus 1 into y of z, already taken as a common. And for the third term, y of n minus 2, the transformation is z power minus 2 y of z. And fourth term, y of n minus 3, the transformation is z power minus 3 y of z. And the last term here, it is a fifth term, y of n minus 4, the transformation is z power minus 4 y of z is equal to two terms in the input function, x of n, the transformation is x of z, x of n minus 2, the transformation is z power minus 2 x of z. On both sides, we can take here the y of z is a common and the x of z is a common. Write as output by the input y of z by the x of z. 3 plus 5 into z power minus 2 and denominator 1 plus 0.5 z power minus 1 plus 2 into z power minus 2 and 3 into z power minus 3 and 0.8 into z power minus 4. Nothing but it is a x of z, calling it as a system function or the system transfer function, output by the input. Got it, my dear students? Now, you can find out the factors here. You can find out the factors in the denominator, and by using the partial fraction method or residue method, whatever the method you can use to find the impulse response of the h of z. Impulse response of the h of z. Got it, my dear students? So they will get the four factors here, the 4 poles, or convert, first of all, convert into the positive powers of the z. Then after you can find out the poles to get the impulse response of h of n. Impulse response h of n. Got it, my dear students? And another example also we have here, y of n is equal to y of n minus 1 plus, or the y of n is equal to y of n minus y of n minus 1 plus y of n minus 2 plus x of n minus 1. It is equal to only, my dear students. This is equal to. Apply the z transformation on both sides. Y of z is equal to z inverse y of z, z power minus 2 y of z plus z inverse x of z. Take the two terms in the left hand side. 1 minus z inverse minus z power minus 2. Take the y of z as a common. Write the y of z by the x of z and convert into the negative powers to the positive powers. The z by z minus 1 by 2 whole square minus 3 by 4. Okay, z by z minus, it is in the form of cos, not the cos, okay, cos only. Z by z minus a whole square minus b here. Using that, any one of the function we have, we can multiply that a power n v of n. It is now, it is a power n into cos function also will get. Whenever you can find out the h of z in the impulse response. But here we are finding only the system function only. For the second example and the third example, we are finding out only the system function. If we want the impulse response also, by using the partial fraction method or any one of the method, use that and find out the impulse response. And here it is a direct function only. Z by z square minus z minus 1, it is in the form of z by z minus a whole square minus b. It's a constant here. To get it here, the constant, h of z by z is equal to x of z by z, like that. Okay. And the next example, fourth example also, the y of n is equal to, or the y of n is equal to y of n minus, it is not the function, there is no anything here, y of n minus 2 minus 3 into y of n minus 1 plus 2 into y of n is equal to x of n minus 1. Apply the z transformation for this. Y of n minus 2. Y of n minus 2 is y of z into z power minus 2 minus 3 into y of n minus with z transformation is z power minus 1 y of z, and 2 into y of z, that is equal to x of n minus 1 z transformation is z power minus 1 x of z. So take the y of z as a common in the three terms. Y of z by z, x of z is equal to z inverse, and the 2 minus 3z inverse plus z power minus 2. Convert into the positive powers, z by 2z square minus 3z plus 1. Write the factors in the denominator, 2z minus 1 and z minus 1. Using the partial fraction expansion method, you can get the a is minus 2 and b is 1. And impulse response for the h of z, h of n is equal to, it is in the form of z by z minus a. What is the a here? 1 by 2. So minus 1 by 2 whole power n mu of n, and z by z minus 1, 1 power n mu of n. So without giving any ROC, you can write it is always in the right hand side only, my dear students. Here, why we are writing it's a mu of n without having any ROC is a greater than, or it is a less than, or in between. If they mention, you can write down whether it is in the right hand side or the left hand side or in between. If they not mention, directly they are asking to find the impulse response without asking any ROC or given in the ROC. Default you can use in the right hand side only. Minus 1 by 2 whole power n mu of n, and the z by z minus 1 is 1 power n mu of n. Got it, my dear students?